Chapter number 6, standard is 8th. Lecture name is a square and a square root. We will see what is a square, what is a square root, and details we will be discovering it in details. Let's start. A square and a square root. Introduction. What is the introduction of this? Are you ready? Now we know that the area of a square is what? Area of a square. When we calculate the area of a square, then we just multiple side by a side multiple side. This gives us a area of a square. This is also a formula of calculating area of a square, where side means length of the side. This is one side, this is another side, and side of a square has how much? Four side. Side of a square has four side, and here we are taking two sides. Will it make sense? Of course it will make sense. For area we apply at the end what? A square, so that we can represent. Yes, we are representing two times. Here side of a square side of a square would be how much? This one. This is area of the square. If we take two sides of a square, then area would be 2 to the 4. Here at the end of the answer you will have to apply this a square, then it will be complete area of the square. This is a square you will have to complete. That's why we take a half side of the shape to calculate area. Here we have three sides, so for 3 we will take here we are taking three sides, but actually we will have six sides. Here we take 3, so 3 3 is a 9. 4 again we have 4, but actually we have a 4 multiple 4, 16. We have 8 sides. So if you have a 5 sides, then area would be 25. 25 will be represented. Sometimes it can be represented as 5 raised to power 2. Sometimes 6 raised to power 2 will be written. Then meaning of this would be just a 36. For A is a side, A is also side, and when we will multiply both, then both will be A square. A square number. What is special about the number this and other? 4, 9, 25, 64, such numbers. Since 4 can be expressed as a 2 multiple 2 raised is equal to 2 raised to power 4. 9 can be represented as a 3 multiple 3 is equal to 3 raised to power 9 is equal to 9. Like that we can represent a lot of numbers. All such numbers can be expressed as a product of the number with itself. If we have a product, when we will multiply a number with itself, then there is a product should be same. For example, we have 9. This is product. We are considering that this is a product. Now, what would be that number when we will multiply that number with itself 1 times more? Then this product should come. So here for 9, so we will take 3. When we multiply 3 by itself 1 time, then of course we will get 9 product. Like that numbers are called as a square number. With itself, such number like 1, 4, 9, 16, 25 are known as a square number. This is also number, but what type of number? So you would say a square number. A number which a number which product would be which product would be two, a number which is a product of two numbers. When we will multiply those numbers, then we will get our product number, a square number. You know what I am saying. We have 25, then what would be product of 25? Of course 5 multiple 5, 5 multiple 5. So remember, both should be same. Either you are taking 4, either you are taking 3, either you are taking 2. So both should be same. 2 2s are 4, not 2 3s are 2 5s are no. Both should be same. In general, if a natural number m can be expressed, in general, if a natural number m can be expressed as a n square, when n is also a natural number, then m is a square number. M would be a square number. N square is equal to m. M would be a square number. So here m is a square number. Is a 32 a square number? We know that 5 raised to power 2 is equal to 25. We know. And 6 raised to power 2 is equal to 36. If 32 is a square number, it must be the square of a natural number between 5 and 6. But there is no unnatural number between 5 and 6. Therefore 32 is not a square number. Natural number. Remember, you should take natural numbers to represent a square number. For example, 432, 432, both should be same. So 32, 8 4s are 32. So 4 8s are 32. So both are different numbers. Both are different. 4 is a something and 8 is a something else. So 30, there are more numbers that are not considered as a square number, like 32. 36 is a square number because product of this would be 6 multiple 6 and both are same numbers. After multiplying, we are getting 36. Now next we have what is special about this the number 4 9 25 64 and other some such numbers since 4 can be expressed. It is a done. It is a done. Now properties of square numbers. Properties of square numbers. What are properties? Properties are also important in the discussion of rational number. We saw properties of a rational number. Same here, properties of a square number. Properties will be more important. Importance of properties will be more. Consider following numbers and their square. We have a number and the square of this will be 1 raised to power 2. So 1 multiplied 1 would be 1. A square of 2. A square of 2 would be 4. A square of 3, 9. Just we will multiply this by itself. We will multiply this by itself one time. So 4 multiple 4 would be 16. From the above table, can we enlist the square numbers between 100, 1 and 100? Are there any natural numbers up to 200? Okay, these are no squares and these are numbers, simple natural numbers. Study the square numbers in a table. In the last slide, what are ending digits? That is a digit in the ones placed of the square numbers. All these numbers end with 0, 1, 4, 5, 6 or 9 at units place. None of this end with 2, 3, 7 or 8 at units place. Can we say that if a number ends in 0, 1, 4, 5, 6 or 9, then it must be a square number? Yes, of course. Let's see how. Here we have this is 6 5 6 9 4 1. This is coming. Studying the following table of some numbers and their squares and observe the ones place in both 1 1. This is both same. This is about same. What is happening here? Main focus is here unit at unit place. This is one. In this, what is happening? 1 is coming. Same here. 4 is coming. Same here. This is 9, and here 9 is coming. 6 is coming. This is 4. Here is a 4, and here is a 6. So here at the end is how much 6. This will happen with a square numbers. With a square numbers, this will happen. 5 25. Then here also 25. Here 36. Also here 6. Last digit number. Here you can observe 6. Here same 6. 9 9. This is 7. This is also 7. That's why this is 9. Then this would be also 9. This is Z. This is Z. This is 4. This would be also 4. This is 9. This is 9. This is 1. This is 1. This is 0. This is 0. This is 0. This is 0. It happens with a square number. Here we have the following square numbers. The following square numbers end with the digit 1. The following square numbers end with the following square numbers end with the digit 1. A square. This is a square with end with the digit 1. 181, 121, 361, 441. So number of this would be 1. Number of this would be 9. Number of this would be 11. Number of this would be 19. If a number contains 1 0 at the end, its a square have 2 zeros, and if a number contains 2 zeros at the end, its a square have 4 zeros. For example, it has a 2 0, so a square of this would have how much? 4 0. 2 4 0. 2 4 0. If 1, then 2. If 1, then 2 0. If 1, then 2 0. This will happen. If a number contains 1 0, then a square of it will have 2 0. If a number contains 2 0, then a square of this would have 4 0. If a number contains 3 0, then a square of it would have 6 0. 6 0. Number between square numbers. Let us see if we can find some interesting pattern between two consecutive square numbers, between 1 square and 2 square. There are two non-square numbers, 2 3. 2 3. If we think of any natural number n plus 1, then n plus 1 square minus n square is equal to n square plus 2n plus 1. What is it? We can say that there are 2n non-project square numbers between the squares of the number. We can ignore it right now. A sum of a consecutive natural number. Here we have a sum of a consecutive natural number. Considering the following, we have this square number, and after simplifying this would be 9. It can be 6 plus 3. It can be sum of this sum of 4 plus 5 would be 9. Sum of 3 plus 6 would be 9. 5 square 25. It is a 25. So sum of this would be 25. Sum of 30 plus 12 would be 25. Sum of 14 plus 13 would be 14 plus 11 would be 25. Product of two consecutive even odd 11 multiplied 13 is how much? 143 is equal to this 1200 12 raised to power square minus 1. This both is equal. Both are equal. 11 multiple 30 is equal to 12 minus 1. This would be 11. Multiple 12 plus 1. This would be 13. This is equal to what? 12 minus 1. So it is 11. And multiple 12 plus 30. This is 30. And can we say this is equal to this and this is equal to this? So in general we can say a plus 1 multiple a minus 1 would be equal to a square minus 1. Finding the square number of a number. Finding the square of a number. We can find the square of a number quickly by knowing the method shown below to find the square of a 23. 20 plus 3. 23 can be written as a 20 plus 3. 23 raised to power square would be what? 20 plus 3. By using algebraic identities, we can find a square of 23. So 23 can be written as a 20 plus 3. Then just apply a square, because we are going to find what is the square of this 23. Then 20 into 20 plus 3, then plus 3 into 20 plus 3. Then we will multiply this with this, then this with this, then this with this, then this with this. Then at the end we will get to 529. This is a square number of this. By this method you can find a square of any number by this method. Otherwise you have more option. Pythagoras triplets. Pythagorean triplets. Consider the following: 3 raised to power square plus 4 raised to power 4 raised to power 2 is equal to 3 3 is 9, then plus 4 4 is 16. It would give us a 25. So remember, sum of squares numbers would be a square number. The collection of a non-square number. The collection of a number square non-square number like 3 4 is known as a Pythagorean triplet. 6 8 10 is also a Pythagorean triplet. Since 6 square plus 8 square is equal to 36. 36 plus 64 is equal to 100, and 100 can be written as 10 raised to power square. Formula 2 meter square plus m. Here you will have to apply algebraic identities. A square root is the inverse operation of a squaring, and its symbol is like that. This is just opposite inverse operation. Inverse operation of a square is just this. This is the opposite. When we use this square in our equation, then just we can convert this into a square. For example, 1 raised to power 2 is equal to 1. Therefore, a square root of 1 is 1. 1 is 1. So 2 raised to power 2 is equal to 4. Therefore, a square root of 4 is a square root of 4 is 2. A square root of 4 is 2. How much? 2. A square root of 9 would be how much? 3. A square root of 25 would be 5. From the above, you may say that there are two integral square roots of a perfect square number. In this chapter, we shall take up only positive square roots of a natural number. Positive square root of a number is denoted by this symbol. For example, we have this root 4. Here we are saying square root of 4 is what? 2. This is what we are saying. A square root of 4 is 2. A square root of 25 would be just 5, not a minus 2. So a square root of 9 would be 3, not a minus 3. not just a 3 and minus 3. Now we have a square roots here, you already know. So this statement, this interface, here we are saying 1 raised to power 2 is a what 1, 2 raised to power 2 is a 4, 3 3 3 square is equal to 9. Here we are saying a square root of 1 is 1, a square root of 4 is 2. This is just opposite of this. This is the inverse of this. Just to call it is a different. We will call it as a square root of a 1, a square root of a 16. This side would be numbers. Now we have a finding a square root through prime factorization. Consider the prime factorization of the following numbers and their squares. Each prime factor in prime factorization of the square of a number occurs twice the number of times it occurs in this prime factorization of the number itself. What is it that saying? Prime factorization of a number. Here we have 6 minus 2 multiple 3. No, 6 is equal to 2 multiple 3. This is what is a prime factorization. First of all, we will take 2, then we will take 3, then we will take 4, 5, 3, 5, 4. Now remember prime factorization. So we will start from 2, then 3, then 5, like that. 36 prime factorization of a 36 will be either you can use LCM, otherwise if you now direct, then you can direct. First of all, 2 multiple 2, 4, 4 multiple 3 is 12, 12 3, 12 3 is a 36. Like that you can write, but you will have to start from 2. This is a starting point, and it will happen with all numbers. Here you are calculating LCM of a number. So prime factorization of a number would be like that. Prime factorization of its square would be like that. Here you can observe, here you are getting this 2 1 time, this 3 2 times, here 2 4 3 times, here 2 2 times, and 3 1 time. But in this case what will happen? You will get 2 even times, and 3 even times. Both will be even. Here 2 is, you are getting 2 2 times, 3 also 2 times. Here you are getting how much? 2 to 4 to 6, 2 to 4 to 6. 6 is an even number. Here 2 to 4, this is even number. 3, this is a 2 times, which is an even number, not a 1 time. 3 multiple 3, 2 times, this is even. 5 multiple 5, this is 2 times, even number, not odd number. In this case, sometimes you will get even number, but in this case, all the times you will get even number because of you have a square numbers. That's all. Next, we have finding a square root through repeated subtraction. For example, 80 minus 1 is equal to 80. You can ignore it right now. Finding a square root by division method. We will see it later. This is enough for now. We can move ahead of it. Let's see ahead of it. Now next we have cubes and cube roots. Next we have cubes and cube roots. Today it seems like I am speaking very fast. That's why I am losing my energy very fastly. In this, we will understand about cube and cube roots. Let's see number of slides. We have 8 slides. 8th class standard. Next, we have keywords. We have what? Keywords. Cube of a number. The cube of a number is the raised to the power 3. For a square to the raised power would be 2. 4 cube would be 3. Exponent of a square would be 2. Exponent of a cube would be 3. 3 is exponent. A square is a exponent. Cube is a exponent. Just remember this. Cube of a 2 would be what? Cube of a 2. A square of 2. 4. Cube of a 2 would be just, we are saying 2 multiple 2 multiple 2. 2 to the 4, 4 to the 8. This is how we calculate any cube of any number. Here we have cube of 5. So we will write it as a 5 raised to power 3. 5 raised to power 3. So how to calculate it? 5 multiple 5 multiple 5, like that it is written, and after simplifying it we will get 125 as answer. So 125 is what we will say later, but right now we are saying what cube of any number is what? Just a number raised to power 3. Perfect cube, the numbers 8, 27, 216, 343, these are perfect cube. Perfect squares are 64, 25, 81, and here we have 8, 27, 216, these are perfect cube. What is can we not say that 4 is a perfect cube? No, 4 is not perfect cube. Are called perfect cubes. A natural number n is a perfect. A natural number n is a perfect cube if there exists a natural number m such that m multiple m, it should be m. Remember, numbers should be same. Numbers should be same when we are multiplying them. For example, cube of 5. Then we will take 5 3 times, and this 5 would be same, nothing else. So 5 multiple 5 multiple 5, it will give us another number, 125. The symbol is what? Just opposite of this would be this 3 denotes a cube root. We were saying in the discussion of a square root. What a square root? Here we opposite of this would be what? Cube root. Cube root of 125 is 5. Cube root of 8 would be what? 2. The symbol. Note. The cube of first 20 natural number are given here. 1, these are numbers, and here cube of this one would be 1. Hold on, 1. Cube of 2 would be 8. Cube of 3 would be 27. Cube of 4 is 64. Cube of this would be 125. Cube of 6 is 216. Cube of 7 is 343. Cube of 8 is 512. Cube of 9 is 729. Cube of 10 is 1000. 1000. Now next we have what? Next we have 11 numbers. So cube of 11 would be 1331. These are cubes of number. clear? If you want to remember, then you can remember. If you don't want to remember, then you cannot remember. If you don't want to remember, then okay, it's okay. But we cannot ignore it at all. So next we have this. We can visualize a cube. A cube looks like that. A cube looks like that. Properties of cube numbers. First, the cube of an even number will always be a even number. Even number. The cube of an odd number will always be an odd number. Yeah, this is the main properties. I would like to show you something. Here, observe last digit of this cube. Last digit. What will you observe? Carefully observe. One more. Here, what is happening? Here, something is happening. This one into one. Here we have this. If you have even numbers, then your cube will have at the end. Cube will have last digit even number. For example, here 2, this is a 2, it is a even, so this is also even, this would be also even, this is also even. 3, it is a odd, so here 7, last digit you will have to observe. This is same is even, not even, it is a odd. Now next we have a 4. 4 is a even. Now here you can observe 4, and last digit is 4, it is a what, even, it is a even. 5 is odd, here 5 is coming again, so it is a even. If a number is a even, then here would be even. If a number is a odd, then here would be odd. For example, here 7 is odd, then here would be same. This is what properties. This is what is a properties. The cube of odd number. Yeah, we have seen this. Now next, if the cube number have x at its ones digit or units place, then it always end with the digit as so in the table below. You can ignore it. Otherwise, if you are able to understand, then this you can understand. Example: find the ones digit for 27. Solution: we have 3 3s are 9. So cube number of this 27 would be 3. 3 is 9, 9 3 is 7. Like that we find. Interesting patterns of a cube. Here we have this 1, 1. Then 8 would be what, 5 plus 3, otherwise 2 plus 6, like that. 427, like that. If you have this one, so it would be 1 time. If 8, then of course 1 plus 2 plus 3, like that. Yes. Then this is 2 times. It can be represented 3 times. 3 times as a sum, in the form of a sum. This is 64, 4 times. This is 125, 5 times. 5, not 5 times, 5 terms. Methods to find a cube. Estimation method. That's all. It is enough for you. Whatever we discussed in this would be enough for you. Don't worry. Now we are able to move ahead. A square and a square roots. it is done. It is also done comparing quantities. Let's see this comparing quantities. Chapter is 8, comparing quantities. Okay. Ratio, it is a quantities relation between two quantities which reflects the relative size of the both quantities. It is simply the meaning means to compare the quantities. It is telling you when we compare two or more things, then we get a ratio. Not directly but indirectly we get a ratio. Whatever we are comparing, we will get a ratio. Comparing by division is called ratio. If we compare anything by division, we will get a direct ratio. Quantities written in ratio have the same unit. Ratio has no unit. It does not have a unit. It is telling you. Equality of two ratios is called proportion. Equality of two ratio. If you have 1 upon 2, this is a ratio 1 upon 2. If you again one more, you have 2 upon 6, 1 upon 3 first of all, then 2 upon 3. Then you will realize that both are equal. This type of compare is called proportion. Example, suppose in a class there are 20 boys. Let's suppose there are 20 boys and 40 girls. So number of boys are less as compared to number of girls. Find the ratio of boys to girls. Of course, 20 ratio 40. But after simplifying it, we will get what 1 upon 2. We will get 1 upon 2. Solution here, the ratio of the ratio. So 1 upon 2 is telling you that a boy is just half. Number of boy is just half of the girl. This is what is telling. This ratio is telling you. The ratio of number of boys to the number of girls will be 20 upon 40. After by using fraction, we can write 20 upon 4 equal as 1 upon 2. Thus, the number of boys are half. Yes. This ratio is showing. Boys are half number of girls in the classroom. In terms of ratio, it is written as 1 is to 2. 1 is to 2. Like that, it is pronounced. And read as 1 is to 2. You can see. In the written form, it is written like that. But when we read it, then we read it like that. 1 is to 2. Example 2, find the ratio of 5 meter to 10 kilometer. So 5 and 10 kilometers. So 5 upon 10,000 meter. 10,000 meter. So of course 5 multiple to 1 upon 200. 1 upon 2000, not 100. 5 to say yes. 1 upon 2000. Here we are saying thus ratio of 5 meter to 10 kilometer is 1 is to 2000. This is what is a ratio. We converted kilometer into meter. Remember, units should be same. Then we will be able to convert anything into ratio. Units should be same. If units are different, then you can convert, you can make units the same just by using command. Okay, percentage means for every 100, percentage which means 100, for every 100, 1 upon 100. The result of any division in which the divisor is 100 is a percentage. The divisor is denoted by this symbol, this 100. This symbol is represented as, it is used as a percent. It is as in the written form. This is how we represent, while reading we call it as a percentage. Boys and girls, hold on. Suppose in a classroom there are 20 boys and 40 girls. Find the percentage of boys and girls. Okay, we have read question. So we know 20 and 40, what would be? So can you say 50%? Of course, half. We know that 20 students and 60 students are boys. Hold on. What is the question? 20 boys and 40 girls. Find out the, okay. Here we know that 20 students out of the 60 students are boys. So we can write 20 upon 60 multiple 100. We will get 33.33% boys are there in classroom. Just write how much students are in classroom. So 60. And what percentage of we want a percentage of boys as well as girls. So we can write 20 upon 60 into 100. So this is for boys, and the percentage of a girl will be 14 upon 60 multiple 100. How much? 66.67. So which who has, so this is less. Boys are less in a, number of boys are less in a classroom, number of girls are more in a classroom. Thus the class has this much boys and this much girls, this much percentage of girls in a classroom. Example 2, we have convert this ratio into percentage. Just 3 upon 4, then multiple 100, just simplify it, then you will get, and this should be as it. Then now you will get 25. It is about 100 upon 100, but 100 should be as it, and 100 can be used to simplify it. Now next we have SCT has this is for you. This is for you. This is for you. Cost price, the actual amount that a manufacturer spends to produce a product or to provide this service is known as the cost price. Whatever you see, cost price on a material is a cost price. Price on a material is a cost price. If you take, if you purchase a book, then you can see cost price of that. You can see cost price of that book. Then you will get you will get a price which is a cost price. That price is considered as a cost price. Example, suppose it costs 30,000. suppose suppose it cost 30,000 rupees to a car manufacturer to produce a car, then this price will be known as its cost price. Selling price is what? The price at which a product is sold. I sold my product at this much price, so this price will be selling price. At how much price did you sell your car will be known as selling price. Example, suppose a car based companies sell its car at this much price, then this price will be known as its selling price. Selling price. So cost price can be represented as CP and selling price will be represented as SP. What is the profit? Whatever we sell, whatever is a cost price. If a cost price is less, if we sell anything, if we sell anything after selling, if we sell anything with a high much with a more price and if selling price is more and cost price is less, then you will get profit. Selling price is more and cost price is less, then you will get profit. That's it about profit. The final financial gain that is received on selling a product is known as its profit. In other words, it is the difference between the selling price and cost price. Profit is represented as a P and selling price as P and cost P. If when we will subtract this selling price from cost price, then actual number you will get of a profit. The profit in the percentage form can be expressed as P percentage P upon CP multiple 100. It means profit upon CP. Next we have an atom was manufactured at a cost of this much but was sold at this much. Find the profit gained on this atom. So here you can see cost price is less and profit is more. That's why we can say there is a profit of 500. Find that. So 500 in the percentage just PCP. So 500 upon profit is how much? 500 and CP cost price is 1500. Then multiple 100 you will get this much profit in percentage. This much profit in percentage. Now next we have loss. Of course, if selling price is less and cost price is more, of course you will get the loss. The financial negative revenue that is received on selling a product is known as its source. In other words, it is the opposite of the profit. In simple words, you can understand it. If a selling price is less and if a selling price is less and cost price is more, then you got less loss. Example, an item was purchased at a cost of 1000 rupees but was sold at 500. So suppose you got a loss of 500. Find the loss of this item. 500 is a loss. Now in percentage, Just loss is 500 upon CP. Cost price is how much? 1500. So this is 20, this to 5 upon 10. This is 20, this is 20, and this is 20. So here you got 50%. You got 50%. Sale taxes ST. It is a charge we pay to government when we purchase items. This price of this tax is added to the selling price of an item. Yes, we will see what tax included in our material when we purchase something. Hence, the amount we pay to shopkeeper is then given to the government. We pay to shopkeeper, then shopkeeper will give to the government as a tax, sale tax. So nowadays the price include the tax known as value added tax. Value added tax. Example: a share tax of 5% is added to an item whose selling price is 500. Now this tax will be added in with this. Then this material will be sold in market. Find the bill amount. Now total bill amount of this item would be how much total? So tax required to be paid for the item will be 5. Then upon 100. This is what in percentage. 5 upon 100 multiple 500. 500 is a price. Except tax. Then you are getting 25 rupees. This is what is amount. On this amount you will sell in a market. Hence the bill amount will be the selling price plus a tax. Selling amount will be selling price plus tax. This sum of this would be bill amount. Now next, compound interest. What is a compound interest? It is the interest calculated on both the basic principal as well as the interest earned till the date. It will keep increasing after 1 year, after 1 month, after 6 months. It will keep increasing. If we apply interest of something, for example 500 after 1 month, after 1 month it will keep increasing, your amount will keep increasing. This is what is a compound. Now this is enough for you. Next, let's see next. Comparing quantities. In this PPT, you have examples, you have questions with the formulas. Concepts has been discussed. We have discussed concepts. It is also useful. It will not be better to ignore it. In this PPT, you will get questions. You will get questions. We will understand it. We will explore it later. Now next we have algebraic expression and identities. Algebraic expression, and this is done, this is also done. not this. This also data handling. This is comparing quantities. Now we are here. Mensuration playing with how much? 15. 15, yes. We are here. Algebraic expression and identities. Visualizing the solid shape. Visualizing the solid shape. Let's see. These are shapes. Shapes can be a rectangular shape, can be circle shape, can be like this. There are a lot of shapes in our world. Right now I have a object. This is object. Shape of this object is looking like that. It is looking like that. So shape of this is not exact as a circle. This is something else. Shape of this pen is something else. It can be hologram. It can be uh, shape of this mouse. It is a different shape of this is a different. There are a lot of shapes. A lot of shapes. This is a rectangle. This is circle. As you know, this is a hologram cylinder. We are going to explore this. What are shapes? A shape is a form of an object or its external boundary outline or external surface as opposed to other properties such as color, texture, or material composition. It is what opposed on surface of these shapes. Physics logists have theorized that humans mentally break down images into simple geographic shapes called geos. Examples. We will see it later, but here a shape is the form of an object. We can apply texture on a shape, we can apply material, we can apply color on a shape. This is what we can do with the on a shape. Contents. We will explore first of all 2D shapes, then 3D shapes, then a regular shape, then irregular shape, then let's see number of slides. Okay. Here we have 2D. Let's start with the 2D shape. 2D shape can be summarized by calling them flat shapes. Flat shape. They don't have a space. Just they look front. They look of them can be like 3D, but it is not actually 3D. It can move horizontally and vertically. That's it. It can move horizontally and vertically. Any space that can be laid flat on a piece of paper or any mathematically plane is a 2D shape. As a child, your first drawing probably used basic shapes such as squares, triangles, and circles. A lot of our time we can we can we have drawn shapes of square, triangle, circles in our childhood, isn't it? It happened. A lot of our time we have drawn. So circle, triangle, a square. All these are 2D shapes. Here, 2D shapes. Examples of 2D shapes we have polygon, quadrilateral, circle, Triangle, square, rectangle, pentagon, hexagon, octagon, all these are shapes. All these are 2D shapes. Which kind of a shape? 2D shape. Next we have circle, triangle, square. Here this figure, this is a square, this is a rectangle, triangle, pentagon, hexagon, octagon, polygon, quadrilateral, this is circle. All these are 2D shapes, and all this looks like that. All this look like that. 3D shape, these steps are solid. 3D shape, these steps, no, not steps, shapes. These shapes are solid or hollow. It is a solid, yes. This is a solid. It is not liquid. It is not air. This is solid. They have three dimensions: length, width, and height. Here we are talking about 3D, not 2D. In 2D we will have two dimensions, just length and width, not height. This length and width. But in the case of a 3D, we will have three dimensions: length, width, and height. Length, width, and height. This will look something different. Here examples of 2D shapes, not 2D, 3D shapes. 3D shapes are cube, cuboid, a sphere, cone, cylinder, a square base, pyramid. All these are 3D shapes. It is a tapping mirror, tapping mistake. Now, match the following: cube, cuboid, a sphere, cone, cylinder, a square base, pyramid. Cube looks like that, cuboid looks like that. This is a cylinder. This is not cylinder, this is cylinder. This is a cone, and a square base, pyramid. This is a pyramid. A sphere, a sphere, a sphere is this is a sphere. All these are 3D, and all these 3D shapes look like that. Now, irregular shapes. Irregular shapes are two dimensions. Two dimensional structure when lies in a plane. These shapes will not have all sides equal and all angles equal. Irregular shape is denoted as when all the sides of the shapes are having different length and thick. Okay, irregular shape. Here you can see all the shapes are not equally. All the shapes are not equally. These are irregular shape. Irregular shape. If sides are not equal. Okay. But regular shapes have equal angles and equal sides. For example, regular. Here you can see these are shapes that size of each line segment have same. For example, here side of this would be equal to this, would be equal to this, would be equal to this. This side would be equal. This side would be equal to this. Same this, same this, same this. If sides and angles are equally of a shape, then this type of a shape would be regular. If all sides of a shape are not equally to each other, then that shape will be irregular shape. Map. A map is a visual representation of an entire area of a part of an area, typically represented on a flat surface. The work of a map is to illustrate. You can read it, but if you think that this is giving a importance, it is a knowledge for you, then you can read it. For your purpose, you can read it. Map images. So map images look like that. Yes. Worksheet. This is for you. You can say this is question. Answer is here. Thank you. This was about 2D shape and 3D shape. This was not enough, but as an introduction, as a brief information about this, we discussed in this.